Okay, this is number 14 on the sample final. It asks, what's the OH concentration in a solution made by mixing 65 milliliters of 0.300 molar HCl and 65 milliliters of 0.375 molar NaOH, and it gives you the net ionic equation. So this is a limiting reagent problem. The first step is to figure out your new total volume. You get 65 milliliters plus 65 milliliters, 130 milliliters total volume. Now it's asking you what the OH concentration in the solution is, so you can imply from that that that's going to be your excess reagent, because it would be 0 if it was limiting. So we're assuming that our H plus is all used up to make water. So we're going to solve this by figuring out how many moles we've got of both OH minus and H plus. We have an intuition that OH minus is going to be more, so we'll then subtract the difference to find out how much OH minus is left over, and we'll put that new moles value over our new total volume, which we just figured out. So let's figure out how many moles of OH minus we've got. We have got 65 milliliters. Of course, you should know right away to get it out of milliliters, get it into liters. We have 65 milliliters of 0.375 moles of NaOH per liter. And our ratio is 1 mole of NaOH for 1 mole of OH minus. So that works out to be 0.024375 moles of OH minus. And of course, we want to have our sig fig line. We've got 2 sig figs, so we're going to draw our sig fig line after our 4. So that's moles of OH. Now we'll figure out moles of H plus. 65 milliliters again. Now we have a different concentration, but we're going to, of course, get it out of milliliters into liters. Our concentration now is 0.300. Remember, express molarity as moles per liter. So moles of HCl per liter. And like before, our ratio is 1 mole of HCl for 1 mole of H plus. So that comes out to be 0.0195 moles of H plus. Sig fig line, we have 2, so we're going to have it after the 9. So, like we thought initially, we have more moles of OH minus than moles of H plus, so H plus is going to get all used up in making water. The difference now, so moles of OH minus left is your moles of OH minus 0.024. Draw our our sig fig line, 75 minus 0.019, same sig fig line, 5. So that works out to be 0.004 875. So that is how much moles of OH minus is left over. Now we put that value, so this is moles OH minus left. Put that over our new total volume, which we figured out very first, because we mixed 65 mils of each of these solutions together. So we have it over 130 milliliters. It should be automatic now. You get it out of milliliters into liters, and it wants moles of, or concentration of NaOH, and that is a 1-to-1 ratio. 1 mole of OH minus for 1 mole of NaOH. So now we have moles of NaOH per liter, which is our concentration. You'll notice here that we only have 1 sig fig now. Like I say all the time, when you add and subtract, you must be careful, because it will often change your sig figs. So 1 sig fig, we're going to report 0.04 molar. So this is number 14 on the sample final.